Okay, so it is, we're still going on with the ecosystem project, and I noticed that yesterday, something like 9:30 or so, we got another pull request. So I wanted to go through this really quickly. We got a pull request for bringing in triangle mesh, which will be super helpful for our food in the ecosystem project. So I wanted to review that and hopefully get that merged in if it looks good today. Let's go ahead and check that out. I have no idea if this works in this view. I'm going to go ahead and connect our chat highlighter. So if you all see anything, you can point it out. So with that being done, I think what I can do is come to the files here. We can take a look at them. So the left has like nothing, it's just complete replacement. So it's a brand new file. In fact, if I go to the source, wait, wrong one. If I go to examples, create triangle, it's not here. Oh, so it's not actually showing me. I'm kind of surprised I'm not seeing it in this list. Maybe for some reason my this isn't being updated. Examples, create triangle, examples. Yeah, I don't know why that wouldn't display. Okay, well, regardless, we see that's in the correct location here, I believe. Yeah. All right. So it's just VS Code being silly. Pretty standard, pretty standard. So when it comes to draw, so here's our bringing in, do we bring in create triangle? No, it's on utility. Creating a location. Oh, we're getting the entire size. So we're getting like the entire width and height. And then we're gonna create a triangle. So off of utility, create an equilateral triangle using width and height divided by half. So put it in the center and then have the length of each side be 300. So it's gonna be around. I would assume that top is up and like that. Use the color and then pass in the context. We then can draw it out. So this is two meshes essentially. Well, I guess it's like one mesh. We're going to create a triangle mesh, but there's a function exposed to sort of use that mesh, which is create an equilateral triangle. So if we take a look at that, will this... Oh, interesting. So we're bringing in translation 2 and rotation 2. And we're also bringing in standard F32, the fraction of a pi. So pi divided by 3. N divided by 3. I think that's what it is, pi divided by 3. So that's like 1/3 of a circle, I think. And then here we have our create triangle. So it takes in the points. We're setting it so it has to be 3 of them. It's also a reference to the array of points. We have our color, we have our mutable reference to a context. We then return a new mesh builder of polygon types. So we just put in our 3 different points. We unwrap that, we build the context, and we unwrap that again. I guess because like polygon needs to unwrap. unwrap that. We don't, because we're turning the mesh instead of a result, we have to unwrap instead of the question mark. I think that's fine. Get equilateral points. So this passes x and y, so the position, and then the side, like how long the sides are, and returns these points. So we're going to figure out what the radius is. So as if it's a circle, which I guess like if it is an equilateral triangle, those points are going to be essentially touching those points of the circle around. So that's exactly what we would do. So take the side, divide it by 3, and then get the square root of that. Create a point. Translation 2. Katali, good morning. Hello. Okay, so then they're basically doing the translation to then move around the circle, figure out where to put that next point, and that's where we insert the point. So I think that works. And then we have create equilateral triangle. So what this does is just takes in the location, the length of the side, the color, the context, and it uses these other two functions to then give us our triangle where we want it to go. So I mean, I think this is good. Let's make sure it works. So run the test suite. Okay, so all the tests passed. Let's also run, what is it? Run examples. And here's our triangle. So that's kind of exactly what we want. It's an equilateral triangle. It's pointing upwards. We can always rotate this later in when we're using the code. So all we have to do is just position it, color it. Okay, so everything seems to be working the way we want it to. So let's go ahead and accept this, merge it in. Oh, you know what? One last thing. I want to run cargo FMT. Are there differences? Oh, there are differences. What is that? Let's see. So this is, looks like it put these all into one line. And it put a couple other things here too. So I think the only feedback to put in would be to run cargo FMT. Do I have that in the? I think that's something actually. So I think I'll add that in right now because I don't think I have a good good sort of like feedback for that of how I should do that. Let's see. Social media preview. Where do I go for like the get pull request preview? All right, I'm just gonna add that in to like have a note in the like the pull request template is like, did you run FMT? Did you add test? Did you add update? The other thing. Then I could like, then I'll feel better about like, oh hey, can you please run this? And eventually I'd like to run Clippy too. I was just thinking about that last night. A pull request template should be a file in your repo. Oh, really? Well, thank you, Danny. And also, good morning. Also, you have a first beside your name. What's that about? I haven't seen that badge yet. Oh, hey, you're a 5-month subscriber. You know, I haven't been seeing those notifications come in. So thank you very much, Danny, for the 5 months of subscribing. Yeah, you did. That's a pretty cool icon too. Okay, so basically I want to create what is this? Create template for pull requests. All right. But besides that, I'm gonna sort of undo what we did here. Discard, discard. And let's go bring that in. Okay, so mesh for triangle. I can keep on forgetting that, like, thumbs up is +1, not like actually thumbs up like it is everywhere else. All right, so let's squash and merge this. So we merge that in. Let's go ahead and switch back to master branch. I'm waiting for this to show that we can pull it down. Okay, fine. Git pull. So to update those, let's also run cargo fmt. We'll cargo test one more time really quickly after that. I've never had anything break on me. Okay, then run examples. Just run through these really quickly. They're all good. So let's go ahead and bump the version. So we're adding new functionality here. So I think this is now going to be 070. One question, would you like tests in a separate file, but in the same folder as the functions, or better in the same place? So if it's a unit test and it's just like testing the thing directly and it's not a like integration test that's testing like a whole bunch of things, I think that would be the same file. I want to keep as like the standard of how Rust likes to do it. An integration test, I think, should be in the like the test folder that you have set up. And then finally, the examples are like sort of our ultimate integration test because it has like a visual testing as well. I'm not sure if we're going to be able to do too many integration tests because GGEZ requires so much visual stuff. Okay, so we bumped that version. So let's add you two. Bumped version. No, I didn't. That was the previous one. That was run cargo fmt. Perfect. You'll refactor this afternoon. Awesome. And let's git push this. And cargo publish. And we'll have a new thing that we can use for our refactor. Okay, so while it's compiling that, Guess I don't want, well, I'm on master branch, that's fine. We can start looking around some of this other stuff. So in the ecosystem project, we have what looks like some errors. Oh, some warnings. That's all it really is. Which is good because that means RLS has decided to rejoin us for this project, which is very nice. So what does that mean to us? What that means is we can now make sure we're starting to use our new library for real. Which of course we're going to want to update this to 070 in our cargo toml here. So we'll save that, come back to main. There's really nothing new here. This is going to be our new main. In the library, we bring in the foods and we bring in the walkers. We have our foods, walkers, and utility, which are just going to be stored in general like this. Okay, so we implement the game. And obviously we're just initializing each of these things, so that's fine. In our update, and I guess like we can maybe go through an order almost, or we could just update like this. I'm not exactly sure what the best way to do this refactor is. Okay, that's finished. It's updated. Well, we go through and we initialize the foods first. So maybe we'll do that. So we have our library here. Let's now add foods. So it's actually going to be mod under foods. And we have our new function here. So we're going to try to get away from using these two. And it's warning us because we're not using them. So cool. Let mute foods equals a new vector. It doesn't need to be mutable right now, but we are going to be, pushing food into it. Or maybe it doesn't need to be right now ever, and then it will be mutable off of the mute self. Maybe that's how it is. So actually, this could just be in here. Make that a little bit simpler too. Add food after, so this is number of ticks. We could also refactor this to use like number of seconds too. Because we have that example from Danny showing how we can like use the duration to figure out how long it's been seconds wise, like using the actual clock. And then we can like decide when to add the food on. So that might be something really good to do. So we can say something like every 3 seconds. If I need a comment there, this is a bad name. So add every seconds. And then that will be 3. And then the max food count, like how much food can we have? We could do that as 20. I think that's fine still. Okay, then an update. So this is where we're going to get our mutable self. This is where this foods becomes mutable. So I don't know if we need the ticks anymore. Let's go take a look at the documentation in BBGGEZ for random colors here. Is this what it is? I think it is, yeah. So we're storing the timer in here to sort of like figure out how long it's been. Maybe our foods doesn't need to know about when to add it. It just gets told to add the food. And it's managing all the food. So I can see a couple different ways to go about this. I could say, okay, you need to know the tick so you can choose when to add the food. Or I could just have all the functions for like function add the food. And then in the main library, in update here, we say, hey, let's like see, is it food add time? And then we'll tell it to add the food. I'm not really sure if there's any one of them that are like the best way to do this. Like I've done it both ways in the past, and I still don't know what's the best way. What are your guys' thoughts? Besides that, the only things that this function is, this sort of wrapper is really do. You prefer the first one. The first one is that the this module controls like the time for it to end too. So if I do that, you don't really know why. Yeah, that's sort of like how I feel. Is I don't really know which one I prefer. I think when I do both of them, they're both fine. I just don't know which one is like has the best architecture for adding things onto it. If I keep this stuff in here, we complicate mod and we keep library cleaner. If I put the timing in library, I would be able to do something like every n seconds we are doing something. Like we're adding food on like 1 second, we're doing something else in like 1.5 seconds. Like we could do something like that. I don't know if I care to like have that kind of complication yet though. All right, so for right now, let's just keep it in here. But let's go ahead and use the random bright colors as a what would it be? It'd be a exemplar, an example. So if you need to reuse the time, you put it in the library though. Yeah, that's a good question. Do we need to reuse the time for... I don't think we need to reuse the time right now. Maybe we'll keep it in here, and if we need to reuse the time later, we'll then move it over into live and just sort of be open to the refactor, because that's kind of a strength of Rust, that it allows us to do that so easily. Okay, so we have update. We have our timer. We get to duration to F64. We pass it the delta. Oh, we get timer delta here. We pass that the context, so we get the difference, and I think that's an F64. And then we subtract that from self.timer. So this is just simply an F64. So I don't know if timer is the right word for this. I feel like I feel like I might want to prefer this being something like, I mean, it's like current time. Oh yeah, see, look, we're gonna set timer to 1, and then we're gonna subtract the difference as a countdown. I mean, it is kind of our countdown. For right now, I don't really have a better name to do it, but I don't really like it. Okay, so this is an F64. So our timer, we're gonna start with add every seconds. So in a way, actually, add every seconds. Here's our timer. So let's do that here. This will be an F64. And we'll do this every 3 seconds. Oh, 3.0. So then an update here, we're going to get the difference. I mean, essentially, this is like a delta between add every seconds. So we're going to subtract, right. Oh, and you're updating. Okay, so add every second. So maybe we do need like a timer to store in here. That's going to be sort of working with this. So if I say like, okay, you're a timer, you're also F64, and I want you to be the, you're essentially the add every seconds. So if I put you up here, we leave you. Then we put timer is just basically clone add every seconds, that F64, and store it in there. Now what we could do is say, this is gonna be like when to add it, the food. So the first thing we self.timer. So we take our timer and we subtract. Now we have to get this duration to F64, which is off GGEZ timer. I think you need to multiply the duration to F64 times add every seconds. Really? I don't think I guess I could do that to try to see if it hits 3, but I kind of also like this because I don't think that we're going to miss anything. Because if I multiply that, then I'm scaling it up. And I guess I'm waiting for it to hit 3 or get greater than 3. Is that your thought about like how I would then use that? Because that's every second. I guess I'm not super confident in that math. I know this works, where we take like the delta to this, at least as far as you're concerned. So let's see. The duration F64, that's the difference between the last frame and this frame. So it's going to be an incredibly small number, like less than 1. I think it's in nanoseconds. Oh, is that right? In order to like multiply it to get seconds, and as opposed to nanoseconds. Then we hand it the delta, which is a duration. So basically, we're just getting the duration, which is an something. I'm not sure what it is. Wait, I need to divide it. Yeah, so like that's the thing is like I'm not sure. Let's try exactly this one first and see how it is. Okay, so minus, we're gonna get in here the duration to S64 and the delta off of timer, which is off of GGEZ. So I'm gonna actually pull you over like this. So we need duration to F64 and we need delta. So if you want to run every 3 seconds, it'll be duration divided by 3. Well, let me try that, and then I'll add that in as an experiment to see like if that would like my problem is that I can't visualize the math because that's like not my strength. Okay, so now we have minus the duration F64. We're now going to hand the delta and the context into that. That gives us this timer. So now if the timer is less than, okay. So now if timer is less than or equal to 0.0 and the foods, like we have room for the foods, then we're going to go ahead and push into the foods. We also need to reset the timer. So, this is going to be self the timer. And do I not have context? Oh, I don't have context, so we need you. And then we're going to say self.timer equals self.add every seconds to reset that. And I think that's all we need to sort of add this food every like n seconds. So once I have that, we have some errors. Let's get rid of these. So you need to pull in context. And I think, oh, no more errors. Cool. So let's go ahead. Not that one. Nope. Open terminal. Never mind what you said. We could still try it. Let's cargo run this. One, two, three. Yes, that looks like it's gonna be like once every 3 seconds then. That'd be if you had 1 as the initial state. Oh, okay. So because I have 3 as the initial state, it is really counting down. So that was like sort of my feeling about this. These do not last very long before they fade away and become poison. I don't know if that's like what we really want to happen. I think we can make them sort of die out a little bit slower. But that might be a problem for something else. Okay, so still in the mod. If we want to like try multiply it by 3. Oh, so like what would that? We add multiply by 3 and divide by 3. Was that off of timer? Right, okay, so we want to multiply by 3 and then check to see, because timer would have been starting with 1. But because we're starting timer off of add every seconds, it is exactly what we want it to be. And so we can change this to just dynamically change how many every seconds when we're going to do that. Okay, so that's what's going on, and we like that. We can also set this to be whatever we feel like too. Okay, so we have food coming in every n seconds instead of every n ticks. We update the foods, that's fine. We remove, okay, so I notice also we're adding in ticks here. So we're doing the same thing inside of foods for it sort of like to fade away. And we can maybe, we're probably going to want to pass through the exact same thing, and then the timing is going to be different. So instead of like every 1 second, maybe every like half second, it'll like tick down. Okay, so then self foods. Then we remove all the rotten foods. Okay, so I think that's gonna be fine too. And then in draw, we collect all the food meshes into or we initialize a vector of the food meshes, and then we push those out. And then we draw. What I think would be nice later is we may not even need a draw function, because we could just expose the foods and they'll have the meshes on themselves. So we could probably just get rid of this draw function. So if we get rid of this draw function, I now need to come into the food. So I don't need you open anymore. So now we want to store the mesh in here. So we have that. So type mesh. So when we create this, we're going to want to use our location. Okay. So we have our location here. That's so it's a random location. It's a vector 2, but we can just use the x and the y off of that to get the points to then use our random triangle. Do we have we need our color too. Oh, I see. Okay, so no, not exactly, but we will have a draw, so we can then just draw off of this directly and using the mesh. This is interesting where we have this other like polyline here. So I'm thinking we have the location we have I want to create, let's do the triangle mesh first. So this probably won't just be mesh. We're going to want a healthy mesh, which is a mesh. And then we're also going to want a poison mesh, which is also a mesh. And so I'm thinking like those two separate ones, and then they'll come out and you'll switch from one to the other when it becomes blue. So healthy mesh. We have our utility here, so I think we're going to be able to do utility dot create. Oh, you don't have it. It doesn't. It's not giving me the autocomplete. Just a little bit sad. Let's go see if the documentation is up yet. Yes, it is. So here's this create equilateral triangle. We get the X and a Y and the side and a color. The X and a Y and the side and the color. Okay, so let's do this maybe up here. So let healthy mesh. Well, I guess we do this, so create equilateral triangle. There we go. So create equilateral triangle. All right, so self S. This is going to be location.x, location.y. What's next? Then the side. So like the size. So that's going to be this size right here. Then the color. So we want healthy color. Healthy color is going to be a color new, and I just want none on red, 1.0 on green, none on blue. Oh, and full opaque. Okay, so full healthy color. And then the last thing is, oh, we need a context. So we need to pull in the context here too. Okay, so that should give us, that'll give us a triangle for the healthy mesh. Now we don't have like a weird polyline, I don't believe, for a unhealthy. So I'm thinking sort of like a, we could do rectangle. Or we could create a square. We could just make this a square instead of a triangle. That would work for me. So then we're going to have poison mesh. create square. Okay, so this is going to be our x. So location.x, location.y. Our side is going to be our size. Our color. So now we need an unhealthy color. So this is going to be 0.0 for red, 0.0 for green, 1.0 for blue, and fully visible. Expected type found 0.0. That doesn't even make sense. New. Okay, so all right. Thank you, RLS. That is super helpful. Okay, so color here is going to be our poison color. And then our context. Okay, so that gives us these two meshes. So now our draw should hopefully be a little bit simpler. Now we should be able to come down here. And in the mod, we're not have to do anything because we don't need a draw. Instead, we're going to be looping through all the foods directly off of here in the main library and getting that. Maybe we still do want, because if I add draw back in, all I'm really doing is collecting the meshes. So that might be, here, I'll just do this. So instead of food draw, this will be, we still need to run draw then. Because like there's going to be subtly different. So, okay. Then in here, in draw, okay, so we're scaling the calories. Why are we scaling the calories? Where are we using that? Oh, that's just for the color. That's all we're doing for this. I don't know if I need to scale the calories for the color. I think all I need to do this for is for the alpha. Okay, so that color if self calories is less than. Okay, so if calories is less than 0, color from. Okay, so yeah, so this is we're gonna allow this to go into the negative to become the poison. So that's how we know if it's poison now. So I almost feel that we don't need this. Because we already have the color inside. And so I don't need the scaled calories either. Random number generator, I don't think we need that. Here's where we're creating the meshes. We already have the meshes too. And in draw, we're just returning the spots. Okay, yeah, so we're just gonna return depending upon which mesh it is. Because that's all this really is determining like the points to do. We already have the mesh builder run. I don't think I need the RNG anymore because we're doing the square. Let's try this. Okay, so if self.calories is greater than 0, I don't need to do less than points anymore. We're just going to return directly from in here. This is going to be then self.healthy mesh. Otherwise, self.poison mesh. Expected a result, and we're getting a mesh, so let's just return a mesh here. Okay, that gives us that. Now in here, our food. Okay, so that was for draw. Our food news, when we push into here, we need to pass into context. Luckily, we have that. Now in food update, we're taking in the ticks and our calorie loss rate. It's a U size, so every n ticks, but we're now like tying that to the frame rate. So that's not necessarily good for every system. So I think we should do the same thing we did previously, but instead of every 1 second, we probably want to do this every quarter second or something like that. So we're gonna want to have what was that? So like remove like lose calories every n seconds and timer. And that's sort of it. So calorie loss rate is now going to be an F64 and timer F64. So let's say that this is every like 0.3 every 0.3 seconds. So that's also the calorie loss rate gets cloned into here too. Which means here in update, instead of ticks coming in, we probably just need context, right? Because we have, okay, so game result, context. So we need timer, which is going to have the duration. Oh, come on. I'll just copy over then. Okay, so we have our timer. Oh, look at this. We don't need a bunch of these anymore. Maybe a BBGGEZ function that takes a context and returns delta seconds would be good. Ooh, yeah. That might be true. Let me add that in here. So basically, create function that takes in context. And like returns the difference in seconds. Yeah, that might be good. And I don't need any of you anymore either. Okay, so cool. So we're gonna have our duration to f64 and our delta. So down here under update, we're not gonna have our ticks, but we're gonna have a context. And so we're gonna have to have self.timer equals self.timer minus duration to f64, and this is going to be our delta that we pass in the context. Okay, so if self.timer is less than or equal to 0.0, then we want to self.calories equals self.calories minus self.calorie loss amount, but then we also want to reset self.timer to calorie loss rate. So that'll make it lose calories every 0.3 seconds. So an update here, we're now, instead of ticks, we're going to pass in context, which I think means that we don't need ticks anymore. Or maybe we do. Okay. Food meshes. Mismatch type, expected. Okay, so these are now just a vector of meshes. And I think that's all the food stuff. Let's see if we can get this running soon. Expected type found 0.0, which is literally allowed, unless that's like a comma or something, which no, that should be fine. Okay, so I'm gonna ignore you. Oh, you're right, I do. That's why it's yelling at me there. It's out. I moved it up into here. Okay, so that's good. Thank you, Danny. Okay, so the question mark, we removed it. Oh no. Undo. We don't need the question mark anymore because we're just returning a mesh. Type annotations needed. So let healthy mesh. Oh, I don't need you up here. Just like that. Cannot move out of self.healthy mesh. Oh, okay. So I want to return a reference to this, really. So this will be interesting. So if I return a reference, am I going to need to do lifetimes? So far, no. Mismatch types. Okay, so draw a vector of references. Okay. Um, the trait bound. Okay. I think, can I just do this now? Because it's already a reference? Yes, I can. Okay, perfect. And just warnings now. Perfect. Let's see if this works. Those triangles are really small. We should increase the size of them. But they are showing up. And now I think they're staying a lot longer before they become poison. So I may need to change the rate that they decay. Oh, no, there it turned into a blue square. So perfect. Let's make them a little bit bigger. So our size actually should be probably like 15. Turns out we don't need the context here. Okay, I'm not gonna worry about that. I'm just gonna make the size better. We can look to see how this looks. I think that's pretty good. So that's a decent size. Coding Garden, good morning, CJ. All right, so we have food showing up, and I think that if I change, oh, so we do need to fix that. We need to fix our sort of like the opening and closing of it. That will be we'll do that probably last. So I'll move you back over here. So we can see all these sort of coming in over and over and over again. I feel like this rate too, we have a good number of green and blue on the screen at the same time now. Okay, so back to library. That was setting up the foods. Now we want to set up the walkers. So in here, we have our enum walker, which we're probably gonna, next time we're probably going to make this, change this to like add in the next kind of walker. We have our struct walkers. We create a new one that's just empty. We update. Okay, so when we create new ones, we don't know where to create them. And I think that's the problem, is like we don't know when to create them. So we need to, like, on the first frame, have a like, then we have the context and we can add them all in. So we'll have to have a function for that. But okay, we have, so in our update, we get a random direction, a random number generator. For each of these walkers, we're gonna tell it to walk, and we hand it the random number generator. Oh, you don't need to be mutable. That's all you're trying to tell me. Okay, so we need you to walk. We give it the arena size. I don't see why this couldn't just be arena size here. And we hand it this delta time. Like, the delta time isn't like proper. I haven't set that up correctly, but I'm not sure if like, I don't know. If you all like, I still want to do some research on like how to properly do delta time. I'm actually gonna write that down because I keep on forgetting in between streams. Research how to use delta time. And if any of you have suggestions of like how to properly do delta time, please add it in a comment, or you can pull request or send me a tweet or something. Okay, so we're gonna pass an arena size delta time. We tell it to eat and we pass it in all the foods. We cap the size of the walkers. They can't get too big. Gameprogrammingpatterns.com. Okay, Danny, I am going to trust that. Oh, nice. Okay, I am going to read this later. But thank you. Can leave you over here so you can see all of them coming in. Now here we have this. Every 100 ticks, the walkers spend energy. It's a tough chapter to understand. I can imagine that. It might take me a while to like go through it. Or maybe we should like even spend a stream to go through it. So I want to do the same thing here, and like every n seconds, spend energy for this. Now the question is, should this be the same rate that the food goes down? I kind of feel that it should. But I also feel like maybe it should be different. It took you months or years even to understand the different types of game loops. Yeah. And I feel like I'm just like sort of blindly trying random things. So, I mean, it's a good journey to take. So I think we should do this every n seconds too. Just like up here. So we have our public struct walkers. We have, wait, what was that? I got a notification on my screen and it disappeared before I could see it. And apparently it's gone forever, so that's cool. I don't know if that was somebody else going live or not, or just me. So instead of, I feel that the timer should be in the walker, shouldn't it? I shouldn't have to tell the walker to spend energy. It should just be like a walk. I'll have to pass it the context too, which means I'll need the context, and it will walk and spend energy. No. I should probably have like a walker update. Walker Waka. It should have a walker update, and it just handles these things itself. Walk, eat, cap its size, and spend its energy. So if I do something like this, walker.update, we know that we're going to want to hand it the context, which means we need the context. So I'll probably just do this when we get over. So let's switch over to make it so that walkers is it random Random walkers. Oh, I see why I had done that, because these are going to be like different, like the same, but they're also different. Okay. But still, I want an update. I don't have one right now. Okay, so I'm not going to return anything. So what happens when, let me go ahead and undo this so we can see what we were doing. Okay. I haven't set this up. So we told them to walk. And so we have this walk right here. But I'm thinking we'll just say, okay, well, the first thing we want you to do is self.walk. Well, what do you need? You need the random number generator, which I think we can just store inside of here. And at the beginning of the game, we'll just like let it handle its own. So we'll just do RNG comes in here. Red range. When we create a new random walker, how did I get up there? Okay, so this is going to be a rand thread range. Like that. Did I get it wrong? I did. Oh, you need to pull in rand too? No, I got it. Okay, hold on. Rand. Oh, thread RNG. That's what I was missing. Okay, so that gives us RNG here. You're upset. Failed. Did I not pull in? Yeah, so I need. Oh, you know what? We pull in rand off of here. So BBG rand prelude and also rand like that. That gives us what we want. Which means in walk, we don't need to pull in RNG here anymore. Instead, we just use self.rng. The arena size. And since we want the width and height, we can just destructure this here. So arena width. Okay, and then the delta time, we'll just keep those. Okay, so self-acceleration. So this is fine now. So an update, we don't need to pull you in. The arena width. So we actually need the arena size. And the delta time. Okay, so that lets us walk. So that handles that. The next thing here So you're yelling at us because we don't want to do this. So now we want to say walker.update, and we're going to need bring in, I didn't save you. If I do that, will you now tell me? No, you won't. Arena size and delta time. That's what we care about here. All right, so next, walker.eat. So, and we have to pass it the foods. Well, that means clearly we need to pass it the foods here. So foods go in. The foods is going to be a reference, a mutable reference to a vector of food. Okay. Okay, so we have that, and then we're going to say self.eat. We're going to hand it the foods, and I think that's going to be it. And then we're going to have walker cap size. Self.cap size. And then we have this spend energy every X ticks. So, okay, we'll take you out. So we need to figure out like the timing on this now too. So this is going to be, or actually we could just say like spend energy. Yes, this update, this is where we're going to spend the energy on. So GGEZ, we have context, our game result, and then we're going to have timer, duration as, oh, come on. Carlos is getting upset again. Okay. Fine, I'll just come in here. Where was it? Food? Yeah. Okay, so timer, duration to F64, delta. We also want in our public struct, so we want a timer, F64. And we also want in here a, oh, what is it going to be? It's, this is the lose energy every seconds, which is an F64. Okay, so lose energy every X seconds. Let's just say every 0.3 seconds for right now, but this can be changed. So I'm not sure if I want this to be like tied to the food loss rate. This can be like, that's why I'm not gonna make them the same, even though it kind of looks that they are right now. Okay, so we have our timer. And you. Then in update, we're gonna need the context in here. Okay, so in the context, we're gonna see let timer equals, I guess this is self to timer. And it doesn't really need to be a let, does it? Okay. I do want to keep these separate. Okay, so self.timer equals self.timer minus duration f64. We pass it the delta and the context. If self.timer is now less than 0.0, I wonder if like this entire thing, like I wonder if that's what you're suggesting also, Danny, is like not just return a delta seconds, but like has the time run out. I don't know that, or maybe just a trait for it. That might be interesting too. I don't know if we can, if like a trait would be too complex for this, or no, not complex enough. I'm not really sure what I would want with this. Okay, so we have self.timer is less than 0. So if that's happened, then we want to say self.spend energy, and self.timer equals self.lose energy every n seconds. And the main problem now is our update doesn't pass in the context, which is a problem because we don't take in context here either. Which is a problem because this update doesn't take in the context either. Okay. All the things happened. You could abstract a timer out to a thing that also has an update function that takes a context and do stuff with it. Oh, interesting. And maybe has a reset function on it too. Oh, I could see that. So maybe off of utility we have, so on utility we store a struct. No, we store the ability to create a timer that just sort of counts down on its own, and we just every update pass it the context, and it pass the context, and it will let us know if it's reached zero or not, and then we just call reset on it. That is interesting. I sort of like that idea. So create a timer function utility that counts down to 0. Yeah, if the timer is over, do stuff. Okay, so with this, let's see. Oh, I don't see if it runs. Oh, it doesn't. Okay, so what did I miss? This function takes 3 parameters, but 4 were provided in walker.update. Probably would be better if I saved you. So we have all of our food here. We aren't actually creating the walkers right now. So that's a problem. So that's like the random walker being updated. In mod walkers, we have our update all the walkers here. Then we filter out all the dead ones, and then we draw. But these aren't happening. That's why it's letting us. What are you upset about? Oh, irrefutable if let pattern. Right, because it can't we haven't gotten to that other part. Crazy Wolf, good morning. Which library am I using for game dev? I'm using GGEZ. I'm also using a community library we're building to extend GGEZ called BBGGEZ that we're creating as a the stream community. So let's see. Draw out just gives us all of these. Oh, thank you, Coding Garden. Let's see. I want to also store the mesh on the random walker. Now, that actually might be interesting. The size gets smaller, so maybe I don't want to store the mesh on here because it's gonna get like smaller and smaller and smaller. So I think this is gonna be good then. That's basically creating a new random walkers. We create the library. In update, we calculate our delta time probably incorrectly. We get our ticks. We pass those in. We're eventually going to want to get rid of those. We figure out what our arena size is. Sounds like game dev with Rust is growing. Some time ago, you heard of a library called Piston. You don't know if it's popular. So Piston was popular for a while. I don't know if it still is. Pixel Logic and Party of 27, welcome to the stream. Welcome to the thank you for the raid. Welcome everyone. Let me show you what I've got so you can see this. Currently, I've been refactoring this ecosystem project. And right now, all I have is a bunch of food coming into the arena. We have basically lost our walkers because we're in the refactor, and we're going to bring them back. But right now, we have a bunch of food that comes in, and then after a little bit of time, it turns into poison, and then eventually disappears. And our walkers sort of run over them. They will get smaller and then die. We've lost them. Well, I mean, we're not creating them. That's the real thing. So I mean, it's what happens when you let me create like a little game. Is I invariably turn something into a battle royale between bots, which is kind of funny. Okay, so for those of you who are new and like seeing this for the first time, I could also introduce what I'm doing for this. I am creating a the ecosystem off of the Nature of Code project by Daniel Schiffman. So if you've heard of the Coding Train, he is the host of the Coding Train. He's also written this book here, Nature of Code. I'll share this in the link. I'm choosing this book because you could read it free online. You can also purchase a copy. I do have a physical copy of this book. It's pretty awesome. And it uses processing in a book. Daniel Schiffman on his stream often does exercises from this book in P5.js and processing. And I am doing this in Rust and GGEZ. Yes, I was a sysadmin at NASA for 8 years, specifically at the NASA Advanced Supercomputing Facility, but that was a while ago. Well, thank you. Yeah, it was a very interesting time in my life. I wouldn't trade it for anything right now. And I think that it helped me become like to switch over to development and learn all that stuff. Heck, that's when I learned that I was that I was doing software development, because I had no idea when I was writing like advanced scripts. Okay, so with that being said, can I actually get the foods coming in time? I don't have much time before my stand-up, so I'm gonna have to see what I can get done. For those of you who also aren't aware, like I kind of mentioned this, I'm doing this in Rust and the game engine GGEZ. So this is Rust code. If you haven't heard of it, it's a language by Mozilla. It's actually really fun. Thank you, Coding Garden, for the link to GGEZ. I'll also show you a link to the Rust code. Rust-lang. Rust-lang. This is it. Yeah, no, it is a crazy name. Good game, easy RuneScape. I haven't played RuneScape in forever. I think they were in Java though. Okay, so I want off of the library if I can run off of the first tick. So unfortunately, the way I've got this set up is I need in the struct just to store is first tick. And we're gonna set this, this is a Boolean to begin with. And we'll set this to true. Now the only reason I need to do this is because in my library, we're not getting the context of the game in here right away. So in update here, we'll just have a quick if statement. So if self dot is first tick. All right, so if self is first tick, then we want to go ahead and create all the walkers. So in random walkers here, we're creating new of them. I'm not creating a bunch of them, so we'll just tell the random walkers library here. So we have to have a new function, create walkers. Not sure what I'll need. I'll need a mutable reference to self. I'm not going to return anything. It's just going to update itself in here. So we're going to say self dot do I have self dot walkers? Oh wait, no, it's here. It's not down here. Wrong file. This one. So we have our new, that just creates an empty vector here. So we need a create function in here. So create walkers. We're not going to return anything. We just want to say self dot walkers dot push. And so we're going to just create one walker to begin with. And so we're going to say random walker new. Okay, so we need the arena size. That's a tuple of f32. So it looks like we'll say arena size dot 0 and arena size dot 1. And we also need this the random number generator, which I think we're putting inside. Oh no, we don't have it here. We're just storing it. We're storing it in there. Okay. I think I could, let's like not pass that in. So let's just do this all together. I'll pass in the arena size. I'm gonna run out of time. Let's see. Push the arena size, just push one walker in there. Now in the first tick, I wanna say the walkers dot create walkers. Otherwise, I'm not really doing anything, so I don't really need an else here. All of this stuff is going to happen regardless. Oh, you know what else I need to do? I need to then say self.isFirstTick equals false, so I don't create them every tick. Expected value found module walkers. Well, here, this is self.walkers. That's exactly what I want. Oh, self.walkers, yes. Self.walkers.createWalkers. That's what I wanted. And then it wants the arena size, and so arena size goes in there. And in random walkers, we have new. We don't want to bring this in. This should also be just the arena size. So I can destructure it. So arena width, arena height, F32 and F32. We're not going to bring anything else in. We do have this rand and rand prelude, so I can just say rand create, use my, let's see, grab RNG from that, store it there. I need you up above. Ooh, we do have a random size in here. We can do that next time. We have one error, mismatch types. Expected enums, walker found struct, walkers, random walker. Oh, wait, how do I do that? Oh, I need to do like, because the way I set up this enum here to store these. So this is going to be let walker equals walker, random walker, and then push this into here. Then we're going to push in the walker. Yes, thank you, Danny. No errors. Let's see whether or not. All right, what's the chance this is going to work? I don't actually have time to debug it if it doesn't work. So I'm hoping we get a single walker that runs around the room. So there we go. Coding Garden, are you going live? And it's gonna die of starvation. It didn't. So this is a really dumb random walker. It just randomly moves around. It's not going well. Okay, well, Coding Garden, you're not going live right now, so I can't raid you. Rip the walker. I'll do this one more time. In the meantime, I want to see. Oh, Fun Function is live. I can raid them. What do you guys feel about raiding Fun Function? He just finished the Nordic JS conference, and so he's just doing I think just a chat stream. So he's not teaching anything, I don't think. I haven't been watching though. Do I have a browser over here that has Twitch logged in? No, of course not. Okay. You'll start programming, but it just take, okay. So what I'm gonna do is I'm gonna switch over to my ending screen. And in the meantime, I'm going to log into my Twitch dashboard and we can find, I think, fun function. We can raid him. So dashboard, fun function. I will click the raid button and wait until we're all ready to raid. So thank you everybody for stopping by. It was great having you. Thank you again, Pixel Logic, and all of you people who stopped by. I'm hoping that you all have a great rest of your day. Be kind and good to Fun Function. I won't have time to go over and say hi to him because I've got to stand up like right now, and I do these streams every Monday, Wednesday, and Friday at 6:45 a.m. Mountain Time. That's GMT -6. And with that, I will see you all next time. Have a great rest of your day. Bye. Robert Tibble says, eventual consistency is hard to decide.